Hello everyone, and welcome to Ethereum Core Developer Meeting number 105. I'm your host Hudson, and today we're going to start off with YOLO v3 and Berlin client updates. I think YOLO v3 launched, but let's get the latest from James.
It did launch. I saw messages from Besu and Geth popping around. Was everyone any updates on that or on status for syncing for the clients?
So we just started syncing at Nanamind. We went to some of the first blocks with transactions, and now I'm fixing some of the decoders. So should have it syncing very soon because all the EEPs are there. It's just the serialization things for the network.
Cool.
From the Ethereum side, we are okay. We started from the beginning, and yeah, it seems fine.
And that's Open Ethereum?
Yeah.
Mm-hmm.
And then
Besu's in sync.
Besu's in sync. Well, that's great. So that went up last Friday. And so now while that's syncing, Mike asked a question, is Besu production ready?
So just like to make a note though.
Oh yeah,
I mean, there's been some transactions in the beginning, but I'm not sure if there's actually been any transaction load to speak of. So it's really nice that the clients are syncing, but I suspect that we don't really have a lot of coverage from it.
Okay.
Aside from the basic naive kind of base coverage.
And then is it at a point the fuzz testing work can kind of start?
Yes, it's at that point, but it has not really started.
Okay. I mean, that's good. The 4 updates from YOLO, that's good. So upcoming is doing actual using it for testing, and then also doing fuzz testing for testing. The clients are all syncing. We talked a little bit in All Core Devs this morning, for those who weren't there, about possibility of timing for what's next. Meaning scheduling test net fork blocks and main net fork blocks. And I don't want to like really rush into it, but I wanted to open up the conversation so we could start getting an idea of getting some of these things out and about for the network. I just opened up something is that me?
I can still hear you. Is that what you're asking?
I need to rejoin really quick.
Okay, sounds good. While that's happening, we can continue with the conversation. So basically, yeah, we're going to just discuss some of the timing for the fork blocks on testnet and mainnet. It looks like this morning a few clients chimed in, and specifically we were looking like testnet fork blocks potentially first week of March, and then mainnet last week of March as something we threw out there. Do people have any initial thoughts on that? And I can just repeat what Martin said in chat, that if the last week of March was the aim for mainnet, I'd rather do the testnets even earlier. I'd rather rush and bork a testnet than have too short a testnet time and bork a mainnet. Good point.
What's different between YOLO v3 and Berlin testnet?
Only the transaction, I mean the load. Or did I misunderstand the question?
I think that answers it.
Yeah.
Like we don't have any intentions of changing anything or adding anything or moving anything, right?
No.
No.
Yeah, that's for sure. Um, okay, let's see. Oh, James, are you back?
Yep, I'm back. But you asked what I was going to ask, so that we can just keep going.
Cool. And you'd got some blocks for the midweek, first week of March. But if we were to do it earlier, that would be, what, last week of February then?
So I
I
guess maybe it makes more sense to go the opposite approach. Like, how much time do people think we need to just send out a release for testnets? I'm just concerned, like, if we say it's like the last week of February, like, is that enough? Because we still need to, every client will need to ship a release with the blocks set in them, and then every user needs to adopt those. So I don't know what's like the right kind of amount of time we need for that first step, and then however much time we want to see it on testnets before it goes on mainnet. Yeah, so I'm curious what people's thoughts are on that.
Peter Silagi, didn't you once publish a suggestion on these run times for the networks?
What did I publish?
Didn't you publish at some point like the stepping stones towards rolling out the hard fork in like some DevOps specification? This is how we should do it.
Yeah, but we never actually follow that.
Yeah.
So yeah, my only suggestion was that's different from the current approach, was that we could, as an initial step, we could shadow fork Ropsten or something. Essentially, just create a private network that is attached to Ropsten, and then just plays all the network all the transactions from Ropsten. Just it's mining its own old chain side fork. And then the idea would be that that way at least we would have some transaction throughput and some actual use case and actual test load before actually working Ropsten potentially. But kind of that was mostly my idea on how to do things.
It feels like we might already be doing some of that with the YOLO networks, right? It's not exactly the same thing, but it's.
Well, no, not
Yeah,
really.
we're missing out the transactions.
So essentially with YOLO is just mining empty blocks, so it's not really testing anything currently.
Oh yeah, but I mean the previous versions where we did send transactions on them, right?
Well, yeah, but those aren't really live transactions, so.
Okay, got it. Yeah.
The problem is that these are kind of some synthetic transactions that somebody dreamed up, but they aren't really stress testing any parts of the code. Maybe just running some. Yeah, so essentially it's just some synthetic thing. The only true test comes when you start running live transactions. And at that point, if you fork Ropsten and then realize that there's something wrong, then that means Ropsten needs to be rewound or something, or unforked. Versus if you were to create one of these shadow forks, then at least if it goes to pieces, then Ropsten didn't. So it doesn't damage Ropsten. But we don't really have the infrastructure ready to bridge the two networks and just send transactions across them. So I don't think it would be too hard to pull off, but also it won't be. It probably requires some minimal effort, and somebody would have to do that.
Would that be something other than you guys could do?
Well, I mean, probably any client dev can do. They just, you just need to make a custom client that attaches to two networks.
Yeah. Which is we're already doing that for Ropsten.
I think this is similar to what we talked to previously about having a fork testnet of mainnet when we want to do like testing against real estate load. And you basically need to just fork off mainnet, have a EIP or something like it that on the fork block decreases the difficulty by many orders of magnitude, and maybe change the chain ID. And in fact, in this case, I don't think you want to change the chain ID. I think you want the chain ID to be the same,
So that way you can replay transactions from mainnet on this shadow network. So you can, or Robson or whatever you're forking. So you can get real transactions, like the real mainnet transactions would be playing on this shadow chain, which is just running a slightly different rule set, the Berlin rule set in this case.
So come to think of it, probably what you could do is essentially just launch a private network with a different network ID. That should be, so essentially just Robston Genesis with a custom network ID. So that would ensure that clients who want to join in on this hacky network, they are separated off from the live network and at the networking layer, because that's kind of important so that we don't start screwing with each other's synchronization and whatnot. And if you can get that done, then what you only need is one single node that is relaying transactions. And yeah, I mean, that we could probably hack that together just to have a node running on Robson and just somehow stream it across to another node not running on Robson. Maybe just for every transaction that appears on Robson, just call send transaction on the other side. So that's probably fairly easily hackable together if we want to do that.
And that can be done by someone other than a client dev.
That would require client work.
I mean,
What about
sorry,
the
I mean
chain
the
IDs on the signatures?
Sorry, I mean the forwarding of the transaction. So you wouldn't change the chain ID, you'd only change the network ID. So the network ID would be different, so you don't have different networks, but the chain ID would be the same, so that way all the transactions can be replayed.
But clients are set up to reject transactions that don't match the chain ID.
But the chain ID.
Right, so the chain IDs match for Robson and Shadow Robson. Network IDs do not match for Robson and Shadow Robson.
In general, that sounds like a better direction to go to. Is that something we could do in the next, like in the next 2 weeks, is have that be done and then look at forking Robston the week after that?
So I think doing this, it might work pretty well, but it will also be kind of flaky since probably some transactions would fail that succeed on Robston, which will affect the state, and these state changes will kind of snowball, and eventually nothing will kind of work.
Is there a way we could test something like this? I don't, even if it was not for Berlin, like as kind of the equivalent of the YOLO networks on you know, the next time around. So instead of launching empty networks, we basically launch shadow forks. Because I don't know, it just feels like it might work in 2 weeks if like everything goes right the first time, but given we've never done this, I can see a pretty likely scenario where like it just doesn't work like we expect it, and it ends up taking much longer. And I'm wondering if, yeah, instead of maybe doing these YOLO networks next time around, something like this might be more helpful.
Well, I guess the thing is that what Martin also mentioned, that probably the networks would eventually diverge, simply because you have a different miner and some transactions would get included in different order. And that kind of means that if we create one of these shadow forks, then fairly quick, so I don't know how fast, but eventually the networks will be so much diverged that the shadow fork would just be reverting transactions, because it would have just a different state and all the transactions would be doing stupid things. That's my hunch, but
I think the hunch is correct. I don't know. I also don't know on how long that will take. But I think is if we can make the process of creating a shadow fork easy enough, then we can just run it for 2 weeks or a week or however long it takes to kind of diverge sufficiently and just reset. So basically just reset to the head of Robston, redo the whole thing, and you're back on track and you're back to synced basically.
Yep, that could be done. The only annoying part is doing the initial sync. So synchronizing Robston or even Girly starts to have weight. So if you have to resync every 2 weeks, it gets annoying.
Yeah, it's definitely much easier for people or teams who already have like Ropsten running, because you can just copy the whole folder basically, or your whole database, and then just change network ID and move on. It's much harder if you're not syncing Ropsten already for any reason.
It would be nice if we could, if the next YOLO could all, or like, is the problem that currently YOLO is great for testing clients, but it isn't great for testing what's actually happens with data. So the shadow forking Ropsten would be able to test like real life data. So is there something we could do to YOLO that would then also have that, like thinking in advance, like thinking forward, is there something we could do to YOLO that would have that same property?
No.
No. So it would need to be either one of those two, of like not doing YOLO or something else, or, and keep going. You're going to say something.
No, so the issue here is that you need that all the networks, even the test network, but especially mainnet, it's constantly evolving and the transactions are constantly changing. And even if we somehow try to build some pool of transactions to test things with, probably it will get outdated fairly quickly.
Yeah.
So that's why I think that usually just latching onto a live network is always, it will always get you the juiciest stuff. So I think there was a time when, I'm not entirely sure which hard fork was it, but there was a hard fork where everything went perfectly for Ropsten, and then when we forked mainnet, it blew up fairly quickly. And I don't remember which one, or maybe we realized that it would blow up, and it never did blow up. But there was some issue that even in the past, where some fork wasn't properly tested by not even Ropsten. So that's why we're kind of reluctant. That YOLO is kind of cute, just to test out these synthetic tests, for example, tests that are included at the IPs, just to make sure everybody seems to handle the forks okay.
Mm-hmm.
But the real test starts with the test nets, which we previously broke. We can try not to break it, but
So doing the shadow fork would make it less likely that we break Ropsten.
well, it would be one more data point that things seem okay.
Yeah. It would be conclusive. So is it worth trying to hack together the shadow fork thing this time, or just moving forward with doing a block on Ropsten and saying, okay, let's go?
I think that if...
Go ahead, Micah.
I was gonna say, if the client teams think they have the bandwidth for it, I would say it is worth it to do it sooner rather than later, because I think the same technique can be applied to shadow forking mainnet, and being able to test real mainnet state, real mainnet transactions, even if it gets out of sync in a week, that is hugely valuable for reducing risk for final launch. So I think this general avenue of testing gives us massive gains, in my opinion, in terms of real world testing that we're never going to get from Ropsten or Coven or Gurley or any YOLO network. Like, we're just not going to be able to achieve that. And so I think this is a path that we should try to do. And the sooner we can do that, the better, because risk mitigation is good. But that being said, I'm not a client dev. I don't know if you guys have the bandwidth to actually do that in parallel with the current plan or not.
I think, Martin, you had a comment?
Yeah, I mean, I agree with the assessment that if we have bandwidth, it would definitely be preferable. But then I also think that maybe we should just, I'm usually not very careful about the test nets, and I think we should use them for testing. And if they work, so be it. So I would prefer we just go ahead with the test nets. But that's just, I can see that other people may think otherwise.
Well, just to give you an example of why I think it's problematic, is because, for example, currently, I'm not entirely sure whether the project is still active or not, but Reddit was doing their pilot project of this community token, whatever they call it, on top of Rinkaby. And essentially, this means that Reddit was actually running production to systems, even if just pilot projects, but production pilot projects on Rinkaby, uh, which I think is somewhat forcing or pushing the limits of Rinkaby, yet I kind of think it's somewhat still within the realm of acceptable use.
Even if it
It's a
wasn't, if
bit
they're
tricky.
using test nets more than test nets, we can't really stop people from doing that. They're going to do it.
But yeah, of course. So if somebody's running some full production thing and we accidentally break it, then I won't have sleepless nights. But that doesn't mean we shouldn't thread carefully so that we don't break it too easily.
Yeah, I think that it'd be good if we tried the new shadow fork approach and then push the testnet fork block 1 week out from the last week of February date. So it's the first week of March for the,
March. Yeah.
yeah, first week of March for testnet fork, shadow fork 1 to 2 weeks before that when it gets done is how I think it would be pretty cool. Unless would we be able to get that done in the next 2 weeks?
If it's something we had the bandwidth for doing by the next call, then I'm like, oh, it might be a good idea. Otherwise, I'd say it's worth doing it for the next, like realizing that this is a model we should implement for the next fork and like build that into the process.
My guess is that we could hack something together. Here, the catch is that if you want to shadow fork Ropsten or mainnet, then we need a special fork flag to be able to nuke the difficulty out. Obviously, because if we shadow fork mainnet, we don't want to have a mining pool behind it. So that's an extra feature. So besides changing the network ID and somebody implementing a breach, we also need all clients to support this nuking of the difficulty. And if you want to shadow fork Rinkaby or Gurley, then again, we need a special flag in the clients to forcefully replace the authorized signers. Which again,
and I feel like that will take much more than 2 weeks. Like it'll take, maybe it's easy to implement, but we need to test that the different clients do it right together.
Yeah, so Ropsten and mainnet is probably easier because changing essentially is just an extra fork rule which just drops the difficulty. But the Rinkaby and Gurley nets, that might be a bit interesting because you have voting. Sorry for the background noise. So you have some problems with the votes across this fork threshold.
Would it be okay if I'm like I'm envisioning the coordination of getting all the clients onto this would kind of be hard, but if we had just even one client or so go through the process so that we could set up the process for all the clients to join next time. Is that still valuable?
I think so. I was about to say the exact same thing. Is any of the clients feel like they have lots of breathing room compared to the others? I think maybe it's the real question. If any client devs out there, they're like, man, I really wish I had more work to do.
or maybe like would that be so if like the Geth team would want to do that, would someone else want to join them on that, or would it be okay if
So
Geth?
for me personally, I would rather spend the next couple of weeks on fuzzing than setting up this, actually.
Yeah, and I'm not hearing a lot of other clients talk about their love for the idea, I guess.
Yeah.
So,
If someone wants to do it, then they should speak up now. Otherwise, I'd say we should move forward with the fork of Robston and then realize that this is the better thing we should do next time.
Then I will be quiet. I think idea is good, but we don't know about how much time we will need to properly do it. There is a lot of unknowns. That's problematic part. And burning is something that we pushed a lot. Maybe it's better to leave a shadow fork for the next hard fork that comes.
okay. I mean, that sounds good to me personally.
Yep.
So I guess then we're back to the original question, like what's the timeline what's the delay we want to give people to have a fork block on testnets? What's like an acceptable delay? And this is what, like, I guess first week of March is what was originally proposed. And I don't know, I thought like 4 weeks gives all of the client teams 1 or 2 weeks to ship a release, which has a block, and then it gives 2 to 3 weeks for everybody to upgrade. Do people feel like we should do quicker or slower than that, or is that generally fine? And then we can set, I think it's fine to set the mainnet block. If we want to have 4 weeks or 6 weeks of test nets, we can just set the mainnet block farther in the future, and it's not like we're going to be blocked by working on anything else in the meantime, right? Like the testnet is just going to go along. We'll see it happen. If there's issues, we'll fix them. But I think, yeah, I'm just a bit cautious of like us also breaking the testnets if we set a block that's like in 2 weeks and then half the people haven't upgraded. Yeah.
From our perspective, it's fine to rush it a bit more.
So rather rush it. So would rushing mean that we do the
rush testnet, but not the mainnet? So if you want to push for February, then we're totally fine with that.
Yeah, I'm feeling like there's more value in having more testing time rather than waiting while worrying about the risk of a borked testnet, or that people don't get on fast enough, because yeah, I think there's more value in more testing time is what I'm feeling like.
So could all the clients be ready to fork Robston and all the other ones in 2 weeks? So like next core dev calls, we have all the releases ready. So then we could have it be the middle of the week after that.
Yeah.
Yeah, it should be fine.
Yeah.
Okay, so we're aiming for like the 24th. That would be like say it's like midweek, it would be Feb 24th is when we'd want to target the fork block for the various test nets, right?
That sounds good to me.
Cool. And I guess we can hash out the specific blocks async on the chat, find some nice blocks on every network.
Yes, that sounds good.
Yeah.
And do we want to, so I guess, do we want the release to also have the mainnet blocks, the mainnet block in it? And if so, it would be helpful to just have like a tentative date for which we can also find a block.
The block 1,221, what number is that? 12,111,000 is Wednesday, March 24th.
So that would give us a full month, literally day for day of testnet being live.
Yes.
One question: if we bork the test nets, how the client users we going to go to the older version? That would be more safe to have 2 versions of the clients. One with blocks with testnet, another one with blocks with mainnet. I'm not sure how in the past this is done, but
Yeah, I agree. That's not
I
set
agree as
mainnet.
well.
Yeah.
Because
Cool, but
if we have problem
each
with
client can make
testnet,
this.
it will. Yeah.
Sorry, go ahead, Dragon.
That's the same. Yeah, if you have problem with testnet, it will propagate to mainnet. That's trouble.
Then someone else had something. Was it Micah or?
Yeah, I was just saying that this is a decision each client can make individually. Like if we have a tentative date for mainnet, a client can decide whether to release that in their production clients or not. It sounds like people don't want to, but we don't need consensus.
Yeah, we can wait on the what if we do the for the 20. What was the date we just said?
The 24th.
The 24th. Then last week of March is pretty realistic. We don't need to really set a fork block date now. With that as like a target makes sense. So that
Well,
sounds
I
good.
guess it's then a question like how early in advance do you want to have the releases out with the block? Because I know, there's a lot of folks we talk to that would rather not like upgrade their mainnet fork client, a week before the fork. So that's just the kind of the only thing to consider, because there's not only just the consensus changes that go into the clients, there's all the other updates. And so having a version that there's somewhat that they've run for a few weeks to know that there's not like another issue is important. So like it's not like the end of the world, but I think we it's a bit unrealistic to say, we fork the test nets on the 24th of February, then on the next call 2 weeks later or whatever, we decide the mainnet block, and then we expect everybody to be ready for a mainnet fork 2 weeks after that. Yeah.
If we did the mainnet block in 2 weeks, is that still?
Yeah, I think that's definitely better. Yeah. And it's fine then if it's two different versions of the clients, or one, like Micah said, different teams can make the trade-off there. But yeah, if I think 2 weeks from now is fine, but like 4 weeks from now is probably cutting it very close if we want to have a release and have people have enough time to actually update.
Cool. So then that just summarizing for note taker and the rest of the call we would have clients be ready next Allcore Devs call for a fork of the test nets, and then the 24th we would choose a block for the 24th, and we'd also choose a mainnet block that day, and then clients could decide accordingly how they handle that.
Yeah, that sounds good to me.
Yeah, so we should choose the testnet blocks before the next call, though, right? Like we know it's Feb 24th, we can choose the blocks, basically today on the chat. But then on the next call, we can choose the mainnet block.
Yes.
Unless clients want to bundle both into one release, but does anyone want to do that? Or or I should put it this way, does anyone need the block number before the dates we just proposed? Yeah, I didn't think so. I was just gonna check.
Cool. Then I'd say that's good for now on that, and we can move on to the other things unless someone has last thoughts on it or wants to share. I'd say we've taken a good amount of time today. Hudson, back to you.
Okay, thanks so much. All right, finalizing the ETH66 network specification. That was discussed a little bit in chat, and it looks like some clients had opinions on when to finalize it. I think I was getting at, or can someone summarize the discussion?
Yes. So ETH66 add request IDs to messages in ETH65. Not all of them, because there are also things like announcements which do not have request IDs, but all the things which are on the form request reply. And of those messages, all of them except one are currently, you make a request and the response is a list of things. But one is a bit special, and it's the get block headers, which there's a request which has 4 or 5 parameters. And the current specification adds a wrapping so that all the new messages are RLP encoded as a request ID, and then a wrapping of the previous format. And the observation was made by Peter that we don't actually have, I mean, for the things which are just a list, we do have to kind of do this wrapping, but for this get block headers, it would be nicer to just add the request ID alongside or before the other existing fields. Yeah, because the reasoning being that it was lower on network traffic, a bit smaller, and that's kind of the discussion.
So my concern is I think we're overfitting for a little bit of network traffic overhead. The pattern of what the EIP came in initially was you take the E65 packet and you wrap it in a list, which is being done with all the other lists. And for that one packet there, it's an overhead of like 1 or 2 bytes, 1 or 3 bytes at most. The impact comes into the client implementations. If you're streaming from the RLP data, you'll be fine because you just read, if you're in 66, you just read the header and then read the rest. But I see that there's other clients that do an index-based read of that particular packet, and they're going to have to write significant forked code for that to read the packet twice in 2 different ways. So from a design perspective, keeping it consistent is good, and it's also going to have less of an impact on the client code if we keep it as specified. So that's, the author has a preference for this. I have a preference for this. It's not a hill I'm going to die on, but I don't see the need to make a special case for one packet.
Right. Yeah, let me just add to that actually. So for Go Ethereum, we don't have this streaming thingy, and the original implementation of the spec was slightly cleaner, and the implementation where we have to marshal it, so unmarshal it differently, it is actually slightly uglier because we have to create a new type of message and marshal into instead. So I mean, we didn't go this, don't prefer the smaller network message because it's particularly nice for our client, but we, yeah, thought it was worth it anyway. But I think Peter, you're the like main proponent for the. Do you want to speak on it?
Sure. So my main issue is that it seems we're kind of designing the spec backwards. So we just look at how clients implement certain things, and then we make a network protocol that tries to adhere to the existing code as much as possible. And my biggest problem is that that is a very slippery slope on the long term, because then it means that instead of having clean network protocols, our network protocols will be full of interesting quirks just because at some point or another there was one client that implemented it this way or that way. So from that perspective, if we want to add, so currently the ETH packet, I mean, we have a bunch of requests, and for example, there was a time when we wanted to add a new field to the ETH handshake. That was the fork ID, and that was just simply added as an extra field. And so my question is that if we just added it as an extra field there, and now we want to add the request ID, why is the request ID more special, and why should all of a sudden we add extra wrapping just because? So if the fork ID didn't require wrapping, then adding the request ID seems, I mean, it just seems that we're not catering for implementation instead of.
Actually, it is much cleaner code to add request ID as like a separate field and like the rest of the contents of the packet as a separate list, because like I'm just imagining this in Rust terms. It is much easier to much easier to implement because I can make like a wrapper structure with 2 fields with like request ID and some generic request basically. So this just the separating request IDs out of the general list, it leads to a much cleaner implementation, and I think that should be the way forward.
But why would you want to separate them implementation-wise, the request ID from everything else?
Like I said, because it is simply much cleaner code.
But if the code that processes the request will require the request ID either way, then what did you save by adding an extra wrapper?
So it's enveloping and separation of concerns. When you're matching up packets, that's separate code from processing a specific packet. So if we unwrap the envelope and we have the list of whatever we don't care about and the request ID, and we match it up with existing incoming and outgoing packets, that has nothing to do with whether requesting hash IDs, ranges, transactions. So we process that, match that up, pass that further down, and we isolate it. This is sort of enveloping that's seen in other protocols. The concern of what the request ID matching up or not is disconnected from what the actual content of the packet is. Now about fork ID, why it's different, fork ID was put at the end of the list, not at the beginning of the list. So if the request was to put the request ID at the end of the list, there would be less resistance from me. But putting it at the beginning of the list doesn't match existing patterns when we've revised what our packets have looked like.
So yeah, the only difference I can say is that that peer-to-peer and Ethereum protocols do not have a notion of headers or non-header fields that would, for example, at HTTP or all the other protocols explicitly lay out that you have the metadata fields in the headers and then you have the content. There's no such notion of that peer-to-peer, and essentially this debate is introducing it. But we are not really naming it a header, but kind of treating it as a header. So it just seems we're making a design decision on being unaware of it.
But either way, it's easier when you have separated request ID and rest of package. Because if you want to check REST ID, you will check it in the first layer of your application and just send rest of your package to the process.
Yeah, but it's exactly what I'm talking
easier.
about.
As the Dano said, it's fine. I wouldn't say, I would basically model my code to handle both cases, but it's a little bit easier when you have wrapper on every package.
So I started out.
Go ahead, Peter.
I started out. Okay.
Yeah, so I just wanted to add that this is exactly my problem, that none of us are approaching this, that what does it make sense, how does it make sense for this network packet to look like? What we are approaching it from the direction of, hey, I would implement it like this, so let's make the network packet easiest to process or to consume with the code I would write it with. And that's not necessarily a bad idea to keep that in mind, but I'm not a fan of designing with implementation in mind, or I don't know. But maybe I'm wrong here,
So I started out on the side of most of you guys here, and I was convinced by one particular argument that I think Peter or Martin made, which is that by the time you get down to the request ID, you've already narrowed what you're going to handle down to exactly one packet. That is to say, the actual header is higher up the stack. Like you get in a payload off the wire, and you find out what the message type is. But once you read that message type, you know the exact thing you're going to deserialize that into. There is no more like these are not actually like packets that go together, like that are coming through like one funnel. These are already dispatched. Like you've already dispatched them to their final destination. There's no more like, okay, I've got 4 different packets coming in through a channel that's, I now need to dispatch. You've already dispatched them by the time you deserial it, by the time you hit that request ID. And so for me, that was the convincing thing, is that it's just the key there is that you've already dispatched this down to a single handler. Like you do not have multiple handlers at this point anymore in the code. If the request ID was higher up the stack, like before the message type, then I would 100% agree with everybody else here that we should be, having, an envelope type thing where you have the request ID and then some arbitrary payload. But that's not what we have. We have a message type and then an arbitrary payload. And the message type to arbitrary payload is a one-to-one mapping. It's not a one-to-many.
Yeah, I think that's a pretty good observation. And I think we've heard from all the client devs except Nethermind. Do you guys have any thoughts or opinion?
I'm quite open. I was looking at the request IDs approaches, changes, various changes. Everything seems to be all right, and I'm okay for you to design this one.
Okay, what other opinions are there on this? Because I think, are there two concerns right now? I'm a little lost.
I mean, no, well, I mean, it's just a decision that needs to be made. I think no one is ready to die on any hill. Yes, we're for one approach. It sounds like Open Ethereum and BSO are for another mind. What seems okay with either. I think does that sum it up?
Yeah, does anyone disagree with that one? Or with Martin's assessment? All right, this is when we pull out our coin and flip it. No, I'm just kidding. We're not going to flip a coin to decide this. Um, hmm.
There's someone from like network design philosophy we could ask or like reach out to.
No.
Tiebreaker.
Let's try to decide something here now so we can just ship it.
Yeah, it's an implementation issue more than any kind of network design issue, right? Or like per client implementation, how they've implemented it in the past.
I think that's exactly the debate. Is this an implementation question or is this a design question?
But that's a problem. It is a network design question, not an implementation question.
I guess I meant because of how people have designed it in their client implementations before, it's turned into that. Is that not true?
I think it's more how people have designed it in their heads. So
okay.
One set of people has a mental model that is X, and the other set of people has a mental model that is Y. And those two mental models have different desires because in order to jump sides, you have to change your mental model to match the other side. And so that's of course much harder to do. So neither side, of course, wants to change their mental model because now thinking becomes harder.
Yeah.
And your preference, Micah, was the other one. Like if you were to have one, I just read that Light Client said he preferred the proposal.
Peter's specifically.
So I originally was against Peter, and then I was convinced by the whole one-to-one mapping that occurs higher up the stack. So this is not a one-to-many mapping, which like the current way the EIP is written makes it look like it's a sort of a dynamic dispatch situation or one-to-many mapping, but in reality, if you look at the broader protocol, it's not actually. And so that was what convinced me. I don't know if it convinced other people.
Then are we putting this in the wrong place with the payload? Should it be up with the message ID then?
So we talked about this, and the feeling I got from the conversation was that everybody kind of wishes that it was more like that, but that's a much bigger change.
But if we're arguing correctness, that's the correct answer.
What were you saying, Peter?
So I mentioned we had this discussion on the OCODEF channel too, that you cannot really move it higher up the stack because so the naive idea, or I wouldn't call it naive because that was also my first impression. The first impression idea would be that, hey, we can just move it up into the peer-to-peer stack and then problem solved. The request IDs are handled at a higher level or deeper level, however you prefer it, by that peer-to-peer itself. The problem is that then you end up with a really, really bad can of worms because on one side, request IDs work well for request reply patterns, but you also have network packets which do not follow request reply patterns. For example, transaction propagations. Those are just one unidirectional packets, so you don't have request IDs. And the other thing is that if you, essentially the whole point of request IDs is that you make a request, and then when a reply comes, you can funnel it back to the original piece of code that made that request. But that also means that you need this multiplexer, demultiplexer to constantly track all the currently active requests. Now, if you move this request tracking up into Dev peer-to-peer, it means that you have some deep layer tracking mechanism, which needs to be aware that, hey, this program module is waiting for a reply, but what happens if the reply never arrives? Then all of a sudden Dev peer-to-peer needs to start caring about cancellations and timeouts and whatnots. And that's why I'm saying that that is a huge can of worms to dump onto the Dev peer-to-peer stack.
So we're back to having the implementation drive the actual details.
Yeah, in that case, unless anyone has changed their mind, I would consider this being, I mean, that we let the specification stand as is and not change the thing that we agreed upon back in the day. How does that sound to you, Peter?
Yeah, I can always make my E67.
Снарку хорошо. Он
Blackjack.
растекается. Он утащил твою эту палку для ушей.
Alex Blaser, you're speaking Russian on the.
Oh, I think he's muted now.
This is strange. Yeah, I have everything muted. Maybe misclick. Sorry.
No problem. Okay, so what do the other clients think about Martin's proposal? Is that something people can live with? Is that something that people want to try to find other ways to come to a conclusion or veto?
No, I don't think
So the proposal is EEP 2481 as it is on EEP's Ethereum org right now.
Yes. Yeah, so what I'm saying is that we propose to make a change and we're getting some pushback, and I guess we'll consider that proposal to change it not accepted. And yeah, so.
Okay, and that goes more.
The current EEP looks good to me. I say we should take it and implement it.
Agreed. I could take anyway as long as there's a firm decision on it.
Okay.
And Peter, were you saying something?
Peter's change, so that's not accepting Peter's proposed changes.
Yep, I can live with that.
Okay.
No, so actually, so what I was saying is that essentially this whole ETH protocols are not set in stone, and if you want to evolve them in the future, if it turns out that this was a bad decision, we can always go back and just nuke them out. So.
Oh, that's nice then. Cool. All right, I think we've come to a decision on that. For the note taker, let me say the decision and then someone correct me when I'm wrong. We are going with EEP 2481 as it is written today without any modifications to the PR.
I have one slight request for modification. The EIP mentions that this protocol spec is consistent with the request reply pairs in LES. And that statement is not entirely true because LES has some different methods. And all in all, my suggestion would be not to refer to LES when saying, I mean, in the discussion and rationale session, sure, but when speccing it out, the spec should not refer to other specs because then the whole thing is cleaner. So let's just drop that single line and I'm happy.
Yeah, I'll also, I mean, I have an open PR to modify the spec, and I'll change that PR so it doesn't change the spec, but just adds a test case as a bit of clarification.
Does that sound good to everyone? Is there anyone opposed to dropping that line and maybe Martin cleaning it up a bit, but having the same content?
I don't think it needs to be discussed, really. Let's just move on.
Sounds good. All right. What we got next is EVM 384 update. That'd be AXIC. I'm guessing.
Oh, Exit can maybe do a better job than me. I put the post up, so maybe I was prepared to give the update. So maybe I should. But if Exit wants to give it, he can give it.
Either one.
Great. I will give it. So I'm giving an EVM 384 update. I will talk about our gas cost document and then an Eth research post that I'm trying to bring attention to. Recall EVM 384 proposes 3 new opcodes which cover bottlenecks of a large class of crypto, and it'll allow user-deployed fast crypto systems. The word fast means if we remove the overhead of the system, namely the interpreter loop and things like this, we would approach speed records implementations, but we do have some overhead from the system and things like that. So we're doing the best. By fast, I mean we're doing the best we can given the system, and there are ways to improve the system itself. So there's potential. So first I will talk about the gas cost updates jointly authored by Pavel Exik, Casey, Jared, and I. In case you haven't read it, I'll just hit the main points. I won't go into too much detail. By the way, the links are in the issues for this meeting. So we gave a background. Gas has some inherent limitations. Gas is attackable. So these sort of play into our design decisions. For example, we want simple constant gas costs. We propose 2 gas cost models. Oh, by the way, the gas cost model is a systemic way to assign gas costs to an opcode. There's a model which has some machinery, maybe includes some heuristics, security analysis, and in the end, there's some maybe systematic way to derive the gas cost for a given opcode. And our proposed costs for EVM 384 opcodes, which are AdMod 384, SubMod 384, MolMod Mod 384, are, we have 2 models. The aggressive model costs are 1, 1, 3, respectively, and the conservative model gives costs 2, 2, 6, respectively, for those 3 opcodes. So based on these proposed costs, based on these models, we did experiments just to see what they mean in practice. So we applied these gas costs to metering heavy cryptography, but they are a baseline implementation. By baseline, I mean non-optimized. And the design decision is if this optimization brings too much complexity, don't do it. So we noticed bottlenecks in our experiments. And for example, the implementation optimizations that I mentioned, but also some opcodes are used very much. And they become one of the bottlenecks. For example, push and dupe as well. But in particular, push, there were several, I'll talk about some ways we can get around those bottlenecks. Also, very notable is memory manipulation, mem copies. We copy buffers from one place to another. We do it naively with mload mstore. There are other ways we can do it. So there are ways to fix these these bottlenecks. For example, a new opcode called mcopy, bulk memcopy, would save us thousands or tens of thousands of gas. Maybe a new opcode. Maybe I'm just giving some examples. You can read details. Inverse mod 384 would be a candidate for a new opcode because there are 3 opcodes plus, minus, times, and inverse mod sort of corresponds with division. So maybe there would be some. It would be sort of justified and nice because we have the 4 operations. But I'm not convinced we need it yet. But there are many options. There are more sort of aggressive options to remove these bottlenecks. One of the main ones is repricing. Now there are simple repricings and more involved repricings. The involved ones will require, of course, a model, many benchmarks, arguments, security analysis. But the major repricings would benefit everyone a lot. Even the minor repricings that are not controversial will benefit people. And there are other things we can do, including major changes. But these are more sort of significant and risky on the consensus layer, and we're not dependent on these changes. But we are exploring them. I'll name 2 of them. One is using immediates. Right now, the only opcode with immediates are the push opcodes. And if we had immediates to the EVM 384 opcodes, we would remove the overhead for setting up the I guess, execution context of each opcode. But this could require, this could break some old contracts that were implemented naively, but they were still implemented, so it might break semantics. So we might need versioning to EVM, which we don't have yet. That might be a big discussion and a huge topic. Maybe worth doing, maybe not. That's up to other people to decide. Another one that I will mention is called particle gas cost. Maybe other people call it fractional gas cost. That gives us a higher resolution. I think of it more as gas rescaling. So maybe multiply gas times 10. So we have a finer resolution, within the execution context. And then when we leave, we sort of round down or whatever, or we divide by 10 and round and do the floor. Something like this is, again, a major change. Clients have to be very careful, of course, about security, but there's a lot of potential to remove these sort of system overhead bottlenecks.
Hey, Paul, real quick. I think we had a hand raised from Martin. If we could just get that question in, and then we have about 5 more minutes on this topic till the next one.
Yes, Martin.
Oh, yeah. I raised my hand because I didn't want to interrupt. Really. Do you want to finish? And I just wanted to ask.
Oh yeah,
when
sure.
we're done.
Okay. I don't have much left. So we have figures based on all of these sort of various options. We don't want to be aggressive and say we must do this. We're dependent on this. But this is open for discussion. Some of these more aggressive ones, certainly we wouldn't want to even. We'd want to have a big discussion with everyone involved, and we can come together to a conclusion. And I want to bring attention. So I mentioned fast crypto systems before, but I'm sort of re-evaluating this because I'm trying to bring attention to an ETH research post called "Surveying Precomputation Methods in Cryptography Request for Help." And I think we can design new algorithms. So right now we sort of adopt algorithms that we use locally and just put them on chain, just word for word. We just translate them to EVM and we do the operation on chain. But in fact, we can perhaps come up with new algorithms. There are different constraints. So we notice that on chain we have different constraints than local. And what I call pre-computation methods take advantage of this, that we can take some more time to sort of set up the computation on chain, and then we leave just the very minimal part on chain. So we partition algorithms into 2 parts, and I gave a bunch of examples. One of them, just to give an idea, we have a 5x speed up if we versus on chain or off chain, just by designing the algorithm in a way that we just do the hard part off chain and just leave the on chain part to just be as small as possible. And I'm trying to bring attention to this ETH research post, and we will move to questions, Hudson and Martin.
Yes, thanks. So what I was wondering, so I have been positive towards EVM 384 because it was my, I understood it as being a more secure and minimalistic approach to letting the layer 2 do crypto stuff. But I kind of get the impression now that that may not be the case, because if we go with EVM 384, there will be lots of other things that we also want, these kind of repricing and fractional gas prices and like localized fractional gas prices and like large changes, which like in the end, when we reach there, we might have a lot more complex system than if we just went with the precompiled. So what I'm wondering is, are there any other dimensions where you think that EVM 384 is a better, brings more than going with the precompiled approach? And it sounds like you do think so, that you talk about new crypto systems. Yes, so I'm just wondering, aside from this like simplicity thing, is that what other benefits are there to use EVM 384 over fixed precompilers?
So I don't know much about precompiles. I'll just talk about EVM 384. User deployed innovation. I mean, who could have foreseen CryptoKitties and sort of when you give users the opportunity to, or the ability to permissionlessly innovate, I think some surprising things can happen. So Martin, there's if you build it, they will come element to it, but there is already potential in my research post to design new algorithms and things like this. Where will we be, Martin? There's you can ask other questions. You know, what does the world look like with EVM 384 and without EVM 384? Where will we be in 10 years? What will be obsolete in 5 years? These kinds of questions. And I think that EVM 384 will not be obsolete in 10 years. And it could create a renaissance. We already have interest from cryptographers that want to implement their crypto systems in EVM 384. So there is potential, but I don't want this to be overpowering. The system is itself, the stability is very important. So the core devs know what's best. I can only say that there is potential, but I don't know what the design decision should be. I'm just here to just give some ideas.
I think I can make a proper comment to Martin. I have one very specific case in mind when not even strictly EVM 384, but an ability to work on the elements which are roughly like 258, maybe 260 bits, like modular arithmetics may be handy in the future. Other than this, I think in 10 years, everything which we have now will be obsolete anyway. And like it may be handy, but it still doesn't neglect the fact that hyper-optimized, especially for BLS 12381 curve, in a precompile, which will be de facto standard for ETH 1.0 and 2.0 later on, based on maybe a single C library, is still a great case. But I believe that in 10 years, EVM 384 in its current form, it will be useful, but not for building such a complex crypto systems which we have right now. Not like trying to make a pairing primitive as a smart contract, but for more like simple cases when you actually just need to do modular arithmetic over the modulus, which is a little bit larger than 256 bits. And you will need to do maybe like 100 operations like this, and not the full pairing, which is potentially like thousands, like 2,000 for them. So this is more or less my point. And at this point in 10 years, there most likely will be discussion like, well, guys, how we implement an efficient, for example, lattice-based algorithms, which modulus we choose to make it hyper-optimized because everyone will want it. So like, it would be good to have it, but not like, well, let's wait for another 2 years to implement fractional gas costs and no other optimization, gas cost changes, and everything to make it even viable compared to at least 1 or 2 specific precompiles.
One quick comment. When I say EVM 384, I mean the EVM 384 family of opcodes. So there's already interest from cryptographers for EVM 768, which would be just precisely modeled on EVM 384.
Okay.
It's for the same reason of like one specific recursive case. Yes, you can have it. Would be great to have, but such approach, I believe will be obsolete in 10 years.
Okay, so we got to wrap up this piece. So the two.
Could I just give one question? Alex, when you say you need repricing to make it feasible, I don't really get that. The repricings and all those, other work items are useful, but they are not necessary. And that work, if any of that work is
it just depends what you take feasible. Like I don't take a feasible a 10 times difference compared to the hyper optimized precompile compared to hyper optimized 10 times. Sorry, my bad.
Yeah, I don't think it's 100 times.
I think the pairing over arbitrary points, is exactly at least 10 times. At like even in the hyper optimistic pricing case, when you had your old implementation maybe less optimized, but you had a 1 for every multiplication, which I tested by myself and which I presented in the previous results. So this is compared to the pure naive execution time of your test routine, which I had accessible in the Go repository, the Go fork, the guest fork, sorry, compared to what I was able to run for Blast implementation.
So just being conscious what Hudson said, that we are over time. When you say it's 10 times, if you look at these prices, and if you compare it to the suggested price of the precompile, it's not a 10x difference. So I'm not sure what exactly you're talking about. But what I wanted to mention,
price,
just to close this off,
it's not.
Could I just finish, please?
Yeah.
So what I wanted to say is that if you do any of these repricings or any of these extra proposals, that wouldn't just benefit Event 384, but would benefit EVM in general.
Well, I'm 2 hands up for repricing of everything which is not properly priced and potentially inflates the gas cost by end users. But seems like people are overly skeptical about having multiple implementation of the same precompile. And in principle, there is a precedent that, well, there is a C library for signature verification. If everyone agrees to use the same C library for BLS 1281 as the reference for an EVM to avoid forks, have the same behavior, even if it may be inconsistent at the end of the day, well, it's an exception, but we can live with it. Then if you compare it to this one, to the one which is hyper optimized, not for generic case, not like a legacy of 1962, to the proper special one for this curve, which is a part of the precompiled proposal, single curve, then it's 10 times. Compared to my kind of pessimistic estimates, which are written right now in the precompiled proposal with aspect that, well, we don't take only this fastest one or 2 fastest libraries, but we take any from this batch in the list, then yeah, it will not be 10 times. It still will be few times.
So we need to, we got to take this to the forums. I'm sorry, guys. But thanks so much, Paul, for bringing this, and everyone for commenting. The 2 links are in the agenda, and it's under Paul's comment. I don't know how many down, but yeah, Paul's comment has both links. So yeah, next up is 1559 performance test updates. I think that's Tim.
Yeah, I have a quick update. Can I share my screen actually?
Yeah, sure.
Cool. So just to give some background, one of the concerns about 1559 that was raised a few times on this call is whether we could actually process blocks that were up to 200% full. So 1559 allows blocks to go over twice whatever the gas limit is. And so we wanted to test this out. And the way to do that was not shadow forking mainnet. So we took a slightly different approach where we built the tool that can generate a new network from scratch with an arbitrary state size. And the way we do that is we just specify how many accounts and we create a new smart contract and we specify how many storage slots we want to fill in it. And then we also built a tool that basically spams the network with a large amount of transactions. So to get roughly the mainnet size, we set up a testnet that had about 100 million accounts and 100 million storage slots in a smart contract. And then we synced 4 Besu, 4 get nodes running 1559 on it, and basically spammed the network for almost 2 hours using 1-second blocks, and each block having 20 to 80 million gas per block. This was kind of our first just dry run of the test. We were happy to see Besu and get did not crash. I've linked the actual data in the HackMD if anyone wants to have a look. But next week we're going to do a more proper test. We'll have Nethermine along and try to monitor the nodes as we're going. So I guess my one question was is there any specific metrics or data that people would like to see from this? To just assess kind of general network stability. As we'll be kind of monitoring it a bit more closely the next time around.
Can it be a little bit related to the discussion with the amount of empty blocks? Because if you have a very large block, then potentially you still have a probability that you will mine an empty one during processing the previous one. So can it affect your results a little bit? I mean,
So
it most likely can, but to what
What would you
extension
like
do you
to
think?
see? Like whether the fact that we have big blocks, I guess,
will
yeah, can you
decrease
just
the amount of, like, if you have a big blocks, then you
Yeah.
will have like more empty blocks, which on average will decrease, like, it
But
shouldn't
do you,
decrease
I guess,
that much to some like stable level, or
yeah.
but
Are you saying
it
that
effectively
with
decreases
regards to
abundance.
the block processing or with regards to the transaction fee? So are you saying because we have big blocks, they propagate slower and like we start building just on the header and then that results in more empty blocks? Or are you saying you want to test like when we have big blocks, it raises the fee and that means that there's like a lack of transactions that are willing to pay that fee, which means we then get an empty block to lower the fee?
No, my comment is not related to the fee model. It's just that, like, a naive execution time, like while you process and receive also data for a previous block, not just a header, you still have to, like, miners will mine on the empty block, and well, it will kind of decrease an average bandwidth in some sense.
Got it. What do you think is the way? So,
I can
right now,
I can answer this real quick
yeah, go ahead.
if you want to. So EIP 1559 introduces a new way for miners to prep blocks where they can prep them incrementally. We actually should see, if clients implement this, we should see it actually a reduction in empty block mining, because you can start a block, add one transaction, and because your block is not going to be full, you just add them in order. And then as you see new things, you don't have to prep a whole new block. And so you can do this kind of incremental block production. And so you can start mining a block that has one transaction and then just update to one that's just mining 2, and then just update to one that's mining 3, and update to one that's mining 4 until you get up to a full block. And so I suspect that if clients implement that feature, we should see a reduction.
Yeah, I mean, is it a hard requirement or like it's like a recommendation? I think like it depends on the final implementers, miners, and difficulty of implementing it. I mean.
Yeah, certainly. So this is going to be a potentially competitive feature for clients to compete on. So if you can provide miners with slightly increased revenue, they're more likely to run your client. And so maybe another mine, if it wants more people running its clients, that it might implement this feature. Whereas Geth may decide it's too much work. So this is definitely not a consensus issue. This is just how miners mine. And you may even see some miner implement it themselves and just run it secretly. And you just notice that they have less empty blocks than everybody else.
Yeah, but I mean, miners can even do it right now. Like, they still like losing a small amount of fees by doing this, like very small, maybe 1%. But there is nothing in existing clients yet. So I think this topic wasn't taken as a serious issue in the existing implementation. So like, maybe Martin can answer like why it was never considered, just because no one asked for this.
I don't know if going into that necessarily is still on top. It's still on the thing, but like something that has come up previously, Tim, is like if the network latency between the nodes. So if you have 4 highly connected nodes versus if the nodes are a few seconds apart because one was mined in Russia and one was mined in the US or whatever.
Yeah, so we can definitely, I think for this test, all of the nodes were running in the same instance, but we can definitely for the next test have different regions, yeah.
Yeah, because then if that would simulate more of what mainnet would probably be like.
Yeah, to a very small degree though. Like to be clear, like we're not trying to simulate the whole networking stack here. Yeah. But that's good feedback. We'll definitely try and have nodes in separate regions for the next test.
To briefly clarify, with regards to the exact metric, is it really that we are concerned about empty blocks, or is it that we are more concerned about like maybe a potential increase in anchor rates? Because the interesting thing about 1559 is that like an increase or a slight increase in empty block rate would not in any way affect the throughput of the system, just because like that's what the whole mechanism is about, to kind of balance that out. It would of course kind of increase the variance, and that's probably an issue in itself. But I'm just wondering if like the empty block rate is the important one, or if it's more about like an uptick in anchor rates for like longer processing times. Thanks.
Well, it's more about what's the exact quantity of such empty or underfilled block will be at the end of the day, taking into account potential network latencies and processing time by the nodes. Not like the node doesn't crash and keep up with the network eventually, but that it doesn't affect miners, which are like a huge part of the ecosystem.
But to be clear, though, for most blocks, that won't change. So the reason we're concerned about this scenario is that most blocks under 1559 will be basically the same size as they are today, except when there's like a large spike in demand. And that'll happen like a small minority of the time. And what we don't want is for that tiny amount of time to crash nodes because they were really at their max throughput already. And B, we don't want an attacker to be able to spend, significant resources to then DOS the chain or even have nodes drop off because they can't process blocks. But like under normal operations, there's not like it's uncommon for blocks to be 200% full because the price basically goes up 10x every 5 minutes. So the amount of sustained demand you need for that is incredibly high. So like with regards to just the average propagation and whatnot, that shouldn't change too much.
Although, just to be clear, I don't think that it will be uncommon to see full, like two times full blocks. It's just uncommon to see like a long streak of those. I think just because with proof of work, we have so mumuch variability in block times anyway. So it's that, like, let's say you have a block that comes in 4 seconds after the last block, then that block will almost be empty under 1559 because it will have like a very small set of transactions to include. And so, and likewise, if you have a block after 40 seconds, then that will be overfull. So it's just about these streaks that will occur very, very rarely.
Yeah, just to make sure, does anyone else have anything they wanted to see or any feedback on how we can do the test so that it's a bit more realistic?
I think Micah has his hand up, but I don't know if that's from earlier. Okay. Where do they go if they want to give more feedback? Just the EIP channel and R&D?
Yep, that's the best place.
Cool. All right, next up is all core dev feedback. If you click on that, it has a HackMD file that Tim made with some really good information on feedback he got. Go ahead, Tim.
Sure, I can share my screen again, do this quick. So over the last 2-3 weeks, I tried to talk to basically every client team to understand, what they like, what they don't like about all core devs, how we can make it better. I have this long document with a bunch of feedback, tried to summarize it, to reduce bandwidth. But at a high level, I think people generally like awkward devs. It's not inefficient. It's not very efficient, but people feel that it works. I think the other thing that came up a lot is that there's like this desire to spend more time discussing technical matters on some of the calls and stuff that client developers care about. But at the same time, this is basically the only place where we can get consensus on controversial decisions. So we really need to balance those two things. Another bit of feedback that came up a lot is people feel that it's kind of the bar to bring up EAPs on the call and bring them up repeatedly is sometimes too low, and that tends to take up a lot of bandwidth on these calls. And finally, another bit of feedback that was pretty common is that we tend to be very focused on like the next release and the EAPs that are right in front of us right now, but that it would be good to have just like a higher level roadmap with regards to stuff like, say, the E2 merge and just generally all the long-term things we want to do. I had a whole bunch of different suggestions, but I think 3 things that are fairly easy to do that would have probably a high impact are like just having 1 or 2 calls right after Berlin to discuss the roadmap at a higher level and try to think through not only the next hard fork, but realistically, we probably only have 2 or 3 hard forks before the merge. So, what are the most important things to ship in those, and how do we think about the dependencies between them? With regards to this point about, wanting to discuss technical things, but also needing to have controversial decisions or important decisions happen on the call, one thing that can help is just having like a longer term agenda. So, instead of having just the next 2 weeks, having like 3 months so that we can schedule stuff, like Artem, you posted something about the transaction fees, right? That's the type of things that like, well, right now you can argue it's urgent, but most of the time it's not like the most urgent thing on our agenda. So if we can schedule it in advance and say, look, we want to spend a call, discussing this problem, people can prep for it. And similarly, if we're planning to take decisions on a call, we can also, make that clear, and anybody who wants to be there can show up. People who don't want to don't have to come. And then there's like basically 3 things, I think probably makes sense to have like a longer discussion, probably on the chat, but just, what's exactly the process we want to have to bring EIPs on the call. The idea of having a code of conduct came up a bunch of times. So, this was a simple one that was proposed. And finally, and we're at time, I think a lot of the core developers I spoke to had a hard time articulating exactly where the bridge between like what decision core devs make and what decisions the community should own is. And I think one thing that could help there is just trying to explicitly clarify, what are core developers optimizing for. One thing every single dev I spoke to basically said is like the security of the network. I think this is clear. There's another point around, the long-term like sustainability or success of Ethereum. But then that beyond that, core devs don't necessarily feel comfortable making all of the calls, and having a sort of mission statement or just like scope could help just clarify to the rest of the community, what's the level of engagement that we have with the different proposals. I guess, yeah, we're already at time. I can bring this up async, but does anyone have like strong objections to at least the first 2 proposals? The 3 smaller ones are kind of a can of worms. But yeah, the first 2 are pretty straightforward.
That looks good to me.
Okay, so yeah, I'll get started on the first 2, and we can discuss the other ones later. Nothing in this is really urgent, but and yeah, if there's any feedback, I guess the Alcore Devs channel on the ETH R&D is the best place.
All right, awesome. Thanks so much, Tim, for both of those updates. We are at time. Does anyone have any final things? Okay, the next meeting is February 19th at 1400 UTC. Thanks everyone for coming. Goodbye.
Bye.
Bye-bye.
Thank you. Bye.
Bye.
Bye-bye.
Bye.